What a good day, Miss Moira. This is our research report entitled The Impact of 2Ketones Released from Solid Lipid Nanoparticles on Growth Modulation and Antioxidant System of Lactuca sativa, authored by Paula Frenchera and Javier Espinoza et al. This is the introduction of the study. The growing human population and the need to improve agricultural production yield have led to the use of mineral fertilizer, which have a significant impact on soil quality and human health. Microbial volatile organic compounds (VOC) have emerged as potential tools to mitigate these problems in agriculture. VOCs modulate root and leaf characteristics, fruit production, plant morphological changes, and seed germination. They're effective in inducing plant growth and the root on the foliar level without direct contact through the regulation of physiological and metabolic pathways. Studies have shown that 2-nonanon and 2-tridecanones strongly induce growth in L. sativa by enhancing root development and foliar growth, but their hydrophobic nature prevents their direct application.
This is the continuation of introduction. To address this, nanotechnology has been employed to formulate a carrier for the controlled release of this compound. Solid liquid nanoparticles (SLNs) are a suitable system for the sustainable release of hydrophobic compounds and reduce compound losses associated with environmental factors. This research aims to characterize SLNs used for encapsulation of 2-nanonet and 2-tridecanoate, evaluate the release, and determine the growth promotion and antioxidant system for seedling treated with this compound.
Materials and method. The study focuses on synthesizing solid lipid nanoparticles containing 2-nonanon or 2-tridecanone using high-shear harmonization and ultrasonication methods. The morphology, particle size, and release curves of 2 ketones encapsulated in SLNs were determined using STEM and DLS. The growth modulation of 2-nonanon and 2-tridecanone release from SLNs evaluated using seeds of L. sativa. The total chlorophyll content and panel contents of L. sativa leaf extract were determined using various methods.
Materials and method. The Fulin calculum method was used to determine the total phenol contents. The study also measured antioxidant enzyme activities, enzymatic activities, POX activity, and SLD activity of leaf extract. The results were analyzed using high-performance liquid chromatography, DURA detection, HPLC DAB equipped with the SPD M20A UV VIS DURA spectrophotometer.
They study the use of microbial volatile organic compound as alternatives to mineral fertilizer for soil quality and human health. The research found that 2-nonanon and 2-tridecanone can increase root elongation and seed germination in L. sativa, while 2 ketones released from SLNs modulate root system growth. The study also found that chlorophyll content increased in seedlings exposed to 2-nonanon is encapsulated into SLNs, while it decreased in plants exposed to high concentration of 2-tridecanone. The study also found that the SLN formulation increased electrolyte leakage L. sativa seedlings, while the lowest encapsulated concentration of 2 ketones decreased it. The antioxidant capacity of leaves of L. sativa was also measured, with the SLN formulation increasing its activity. The Folin-Chocatel method determined total polyphenol concentration, and chicoic acid was highly dependent on the treatment applied to L. sativa. Enzymatic components of the antioxidant defense system were evaluated, including APX, CET, PUX, and SOC.
Results. The study investigates the properties and characterization of solid lipid nanoparticles (SLNs) used to control the release of 2-nonanon and 2-tridecanone and their protection against environmental stresses. The SLNs were analyzed using various techniques, including scanning, transmission electron microscopy, dynamic light scattering, and potential measurement. Thermogravimetric analysis revealed that the main weight loss was observed between 60 and 160 Celsius with high concentration of 2 ketones losing more weight.
The controlled release of encapsulated dose of 2 nanonon and 2-3-canonon show greater release as the dose increasing. The significant also evaluated to antioxidant capacity of LA sativa. Said, exposed to these compounds, the antioxidant capacity decreasing significantly in LA sativa. Seedling exposed to 2 nanonon but the antioxidant capacity increasing in specific cases.
This is the conclusion of the study. The study shows that SLNs are the effective system of controlled release of 2 ketones with biological activity in agriculture. They maintain stability over time and induce plant growth for 14 days. Some doses of 2-nonanon and 2-tridecanon stimulate L. sativa growth at the root of the leaf levels. 2 ketones can be a plant stressors agent without altering L. sativa growth. The antioxidant capacity enhanced in seedling exposed to SLN formulation, suggesting a possible ecology rule between compound and plant receptors. 2-tridecanon stimulate H2O2 scavenging by stimulating APX and POX.